guys here. We'll just record it and we'll have them up. So from chapter 1-2, how did it go on the chapter 1-2 stuff here? Do you have any questions on any of these? Yes, which one? 7, okay. So number 7, it says, compute and simplify the difference quotient for the function f of x equals 2x squared minus 5. The difference quotient is this. And this difference quotient is actually the slope formula from Algebra 1. F of x plus h is your y2. F of x is your y1. And when you take x2, which is x plus h, minus x1, which is x, the x's cancel out, leaving just h on the bottom. So this is really equivalent to the slope formula, which is also what you use to find the average rate of change between 2 points. And you'll use that today on the performance test review. So this formula you need to memorize. It might help to think of it as y2 minus y1 over x2 minus x1. But your x2 and x1 are x plus h and x. So if you can remember that, it'll help you remember it, the formula. So equals, now f is going to change depending on what function I give you, okay? What this says is take x plus h and plug it in for x in this function. So it looks like this. I'm going to put solid brackets around the entire f of x plus h portion. So it's 2 times x plus h squared minus 5, and that's my f of x plus h term. That's the first part of the formula. Minus. Okay, f of x, it's just the 2x squared minus 5. You can think of it 2 ways. It's a straight substitution. F of x is 2x squared minus 5. Or in function notation, I'm putting x in for x, which gives you the same function, right? If I were to plug 3 in for x right here, I'd plug, if f of 3 would be 2 times 3 squared minus 5. So that's all that I'm doing, all over h. And then I have to run through the algebra involved with simplifying this. So I have this 2 out here. The x plus h squared will have 3 terms. It'll be 2, and then it's x squared plus 2xh plus h squared minus 5. All of that will be doubled. Not all of that, sorry. Only the part up to the h squared will be doubled. And then minus 5, and then minus 2x squared plus 5 if I distribute this minus sign to each of these, all over h. Now, when you double each of those terms in parentheses, you'll notice that a bunch of things are going to cancel. And what should happen on these is all these x terms should cancel, and the constants. So you'll see this cancels, that cancels, and I'm left with just terms that have h in them, right? So 4xh plus 2h squared, that's left. Let's just write that down. All over h, and if I factor out an h from the top, I'm left with 4x plus 2h, and that h on the top cancels with the h on the bottom, giving me my solution 4x plus 2h. So what you'll find out in calculus is that the 4x plus 2h is the equation of the derivative of this function 2x squared minus 5. We'll learn that next year. But this difference quotient is very important. It's important that you can do the algebra that I've gone through with this for any common function that we've seen in here, the rational function, quadratic, linear. Yeah. Yeah. That's number 7. Anything else from chapter 1-2? Yeah. 10? Okay. Nope. I don't want to capture it. There it goes. Number 10. Number 10, we have, this is a quartic, it's 4th degree. We've learned, one of the methods we learned for factoring these is the rational root theorem. In other words, you could use factors of plus or minus 12 over plus or minus 1 would be possible rational roots. The only problem with this one is it doesn't have any rational roots. So if you went through that process, you're not going to find any that work. You can kind of look at the solutions and tell that, yeah, I mean, unless it's either B or C, it could have rational roots. It ends up it doesn't. So the other thing you need to be able to do is see something like a quartic as really just another quadratic equation. As a matter of fact, if I let u equal x squared, the way I would rewrite this is x to the 4th would then become u squared. X to the 2nd would become u. And then I have a quadratic in u, or a quadratic in x squared. It's kind of like what we talked about with sine and cosine. You can have a quadratic that's in another function as the variable. So how does u squared minus 11u minus 12 factor? It's pretty easy to factor. U minus 12, u plus 1. And then the zero product property says, okay, set both of these equal to 0. Except that u is not what we're trying to solve for. We're trying to solve for x squared. So replace u with x squared minus 12 equals 0, or x squared plus 1 equals 0. Now we can see where these solutions come from. The one on the right here is fairly easy. X squared equals negative 1. What does x equal? Plus or minus I. Square root of negative 1 is I. So plus or minus I. And this one, x squared equals 12, and so x equals plus or minus the square root of 12. Well, square root of 12 simplifies to 2 root 3. And so the correct answer choice is the one that has plus or minus I in it, as well as 2 root 3 and negative 2 root 3, which is answer choice D. That's number 10. That's from chapter 4. Other questions from the chapter 4 stuff? Anything else from chapter 4?
Your video covers this?
Oh, we did. We did. Go back in your notes. Just let me know. Number 8. Yep. Okay, so back in chapter 1, 2. So anybody else on this? We got the factoring down? What's that? Yeah, we're going to look at number 8 first.
Is this on a video?
I'm making a video right now. Yeah.
You can't.
Yeah, a lot of the background noise is just that.
No, I'm actually.
Okay. Number 8. If you want to find the average rate of change of sales from week 3 to week 7, you're finding the slope of this line that I just drew between those 2 points. So to find the slope of that line between those 2 points, m is equal to y2 minus y1. Well, y2 looks to be, well, your choice here. But if I call this coordinate 3, 6,000, and this coordinate is 7, 4,000, then y2 might be the 4,000, y1 is the 6,000, over 7 minus 3. So 4,000 minus 6,000 is negative 2,000 over 4, which is about negative 500. What are our units here? Dollars per week. So that's it for number 8. So average rate of change is just finding the slope of the line that connects the 2 points on the curve. And if the curve happens to be a line, it's just the slope of the line because it never changes. All right. Yep. Number 12 from chapter 4. This is one where you could, since this is the calculator, okay, you could plug it into your calculator and then get an idea of how many real roots it will have. That would help. We don't need to do that on this problem. We can actually look at possibilities here for roots. What are my possibilities for roots? Let's start making a list. What are values that could be roots, rational roots of this? Plus or minus, what's the next one? 3. Okay, and then plus or minus, and so on. All we're doing is taking factors of 45 because it's factors of 45 over 1. So it ends up being the factors of 45 that are possibilities. Hopefully these first few, one will work. Looking at the answer solutions, it looks like one of these will work. We'll see. So notice on here, 1's not in here, and so unless it's a none of these, I would maybe go on to the 3, negative 3. So what we do is let's just take positive 3, see if it's a 0, and what we're going to do is synthetically divide it into this, or you could just plug 3 in and see if you get 0. The reason I'm synthetically dividing is if 3 does go into here and is a 0, then I'm going to reduce it down to a third-degree polynomial, so I get both of those things. Yeah, well, once I get to a second degree, yes. So bring down the 1, that's 3, that's negative 1, negative 3, that's negative 7, negative 21, that's positive 15, positive 45, and 0. So 3 is one of the zeros. And that was a good choice because all 3 of those, A, B, and C, have 3 as a possibility. So now, it's possible that 3 could be another 0. I could try 3 into this again. I don't see any with 3 listed twice, or 3 as a double root. It might be worthwhile to try negative 3 next. We know that 2 and negative 2 aren't possibilities. So let's try negative 3. Just go like this. Bring down the 1. That's negative 3, negative 4. That's positive 12. That's 5. Negative 15. And that is 0. And so 3 and negative 3 are my 2 rational roots. We see that by synthetic division. I'm left with the following quadratic. X squared minus 4x plus 5 equals 0. At first glance, it looks like it's maybe factorable, but when you play with the signs a little bit, you find out that it's not. It's one of those ones that looks like it could be, but it's not. So we use the quadratic formula. X equals opposite of b plus or minus square root of b squared, which is 16, minus 4 times a times c, all over 2 times a. And 16 minus 20 is negative 4, right? So we get 4 plus or minus square root of negative 4 over 2. Well, negative 4 is the same as 2i. That's how we get the I in here. This is 4 plus or minus 2i over 2. And what do you notice is common to each of those on the top? 2. So divide 2 into each one, you get 2 plus or minus I. So we have 3, negative 3, and 2 plus or minus I, which is answer choice B. So this would actually be in the no calculator part of your test, which is the majority of your test. You'll have something like this on there. I would ask this in the no calculator. I allowed you to use the calculator on this so you can check your...
Since it's no calculator, is it going to be fair?
I wouldn't count on it.
Not the whole math.
Only when we need to. I don't think I will. I didn't last year.
Everyone else did last year.
Not here.
Why?
All right, chapter 5.
You're going to be back after this.
We don't need a curve if you have a normal.
distribution.
Yeah.
But what if that's
Yeah. But you can often save things so much data if I put 0%.
I don't want you to try it.
Alright,
To try to get it
that would work.
I know how I could do it. Let's just answer E for every one of them. Or at least for this.
Right, chapter 5, guys. Chapter 5. I've had several ask me on number 18. What do I do on number 18? When you have a variable power, you can always take logarithms to bring that power down as a factor. Okay. So number 18, we take ln or log base 10 of each side. You could actually do log base 10, and that would cancel this out. That would be a better choice. But ln work every time. What will happen is the x moves out in front. So you have x ln of 10 equals ln of 35, and then divide each side by ln of 10. So it's ln of 35 over ln of 10. What you should recognize this as is the change of base formula. This is just log of the argument over log of the base. And so solving an equation like this involves taking log of each side. If I had taken log base 10, even better yet, log base 10 of 10 to the x equals log base 10 of 35. By the properties of logarithms, this just leaves me x. And so x equals whatever log base 10 of 35 is, and I can then punch that into my calculator. If this were on the no calculator part of your test, I would have to leave the answer in one of these forms. Okay. But in this case, I asked you to find the decimal approximation, and you got it. You could also look at this and say, I mean, in a calculator portion of this is really easy, but just plug in the different values so it makes it almost a trivial question. Right? So this is something that I have moved to the non-calculator portion stuff. Yeah, because you could leave your answer in this
like
form.
that.
Yeah. And here on the calculator portion, you don't even need to know the equation solving method to bring the x down. You could just plug in 2.3, 1.25, right? That kind of makes it a trivial question. It's not really worthy of a pre-calculus understanding. All right. But in this review, it's in the calculator portion. So any others in chapter 5? You want to see? What is log base 10 of 35? What is log base 10 of 35? Or, here, better yet, which ones of these could you rule out and why? Which could you rule out? What's 10 to the second power? So 2 or anything bigger than 2 is not going to work, right? It's got to either be B or D, yep. Yeah.
Are there more that I think you put on
Just anything where I don't ask you to change it, that's cool. Yeah. Which one? 19. Oh. Okay, number 19. 19 would be an example of one I would put in the no calculator part. Here's why. 19, you're just rewriting this. So number 19, first thing I would do is move the 3 and the 6 out as powers, okay? And then we're going to just join the two arguments together as a product. So it looks like this. First step would be write this as log of x to the third plus log of x minus 2 to the 6th. Second one would be join those together as log of the product, x to the third, x minus 2 to the 6th. Which is B. No calculator necessary on that. Something like number 20, you need a calculator on it because you're applying the formula.
Wait, do we get the formula sheet?
No, you need to know the formula. Number 20. This is about the only form. Um,
I think it's better with
actually, on the test, I give you the formula for finance. Yeah, it's on the test. It's on the test for the problem when you use it.
Okay. So it's like for some problem.
Yeah. You need to know your difference quotient.
Okay.
Yeah. 21, yep. So all you do on this one is change a base formula. It's just log base 10 or ln of the argument over log of the base. And then you plug it into your calculator and you can round to the 10,000th place. If that was no calculator, I'd just make it leave it like that.
10,000. Explain that one more time, please.
It's a formula. To change the base here, it's
Oh, to change the basis.
log of the argument over log of the base. You need to know the change of base formula. If you didn't remember it, here's what you do. Set that equal to x. By definition, this is the exponential equation, 5 to the x equals 50. Then how would I solve for x? Well, that goes back to the number 18 here. I take log of each side.
Okay.
That moves the x out in front here. You divide. Yeah. And what do I get? So that's using the definition of logarithm to get the change of base formula. Okay?
That's a lot. Well, you gotta be dead to it.
Oh, yeah, they're not dead yet.
They will never die.
Okay, others from the chapter 5. Any others from chapter 5? 22? Okay. The domain problem. So first thing you have to do is take the inner function and find its restrictions. X minus 1 cannot equal 0, so x cannot equal 1. So that's part of it, okay? So guys, start from the inside function, which is, in this case, it's f composed of g. If I switched it, g composed of f, f would be the inner one. Then you're going to take what I circled here and plug it in for x in the outer function. So now what we have is this g of x is in the bottom here where the x is. And so the other restriction here is on the outer function, it's true that 4 over x minus 1 plus 2 cannot equal 0. Do you see how I'm getting this statement? By substitution, the 4 over x minus 1 is going in for the x in the outer function. So that whole x plus 2 cannot equal 0, but this isn't really x, it's really 4 over x minus 1, or g of x. So now we've got to solve this one for x. So I subtract the 2 over, so it's 4 over x minus 1 equals negative 2. Then I distribute, or multiply, cross multiply if you will. So this would be 4 equals negative 2x plus 2. So negative 2x equals 2. And then x equals, or cannot equal, yeah. Let's put cannot equals through that. Some students just leave it equals and at the end translate. I've done that a lot too. So this is x cannot equal negative 1. And so neither 1 nor negative 1 will work. That's this domain restriction, D. It's a set of all x such that x cannot equal plus or minus 1.
Why is it plus or minus 1?
What?
Why is it plus or minus?
Because the inner function had 1 that would not work.
Oh, okay.
All right. What about on to chapter 6? That's our most recent chapter.
The whole thing, please.
We've only done 6 chapters.
Chapter 6.
How long's the...
Yes. Yeah. Okay, 33. I'll wait till it's quiet and then I can go through it. I'll talk over you. right, 33, it says graph the equation y equals -2 cosine, remember that's 1/2 x, so in other words b is 1/2, plus 1 over the interval -pi to pi. So kind of threw that in, -pi to pi. So first thing I like to do is find the midline. The midline is going to be at 1, right? So midline is at 1. So vertical shift is 1. So let's go ahead and draw that midline there. Draw a dashed line through there. The amplitude is 2, so I'm going to go 2 above up to 3, and then 2 below down to -1. So my amplitude will range between -1 and 3. Hard to write on this thing. Okay, so that's up at 3. And then x over 2, that 1/2 is my b. So the period is equal to 2 pi over b, and b in this case is 1/2, so that gives me 4 pi. So the period is 4 pi. We have x over 2 there, so 1/2. Erase this again just so we can see it. So that's the same as having a 1/2 out in front. So period is equal to 2 pi over 1/2, so 4 pi.
Can you divide by 4?
And then, yeah, you can divide it by 4. So what's going to happen here is I'm only showing
1 by 4.
the interval from -pi to pi. Let's see, do I have any kind of a phase shift, horizontal shift? No, no phase shift. So it's going to start at the origin. It's going to start, this is cosine. So it's either going to start high or low. Because it's negative cosine, it's going to start low. And then it's going to, you can divide this by, the increment is divide by 4. So 4 pi divided by 4 gives me pi. So right here at pi, I'm going to be going through the midline. If I were to keep going, it would top out at 2 pi, but look at what I'm asking you to graph it over, -pi to pi, right? That's why you're seeing what you see in the answer sheet. Over here we have -pi, and that's where it's going to go through the midline again. So it looks like just half of my cosine function. It's kind of like a parabola, but it's not. If I were to continue here, it would go up to top out at 2 pi, and then also up here at -2 pi, but those are outside the interval I wanted to graph it on. So that's 33. The other one was 36, right? Yeah. So 36 is another one of those where it's not on a unit circle. This is a coordinate. And the coordinate says if cosine of beta, let's see, find cosine of beta if -4, 5 is on the terminal side. So -4, 5 would be 1, 2, 3, 4 to the left, 5 up. So here's my coordinate out here, -4, 5. I've got to find beta, the angle formed when I draw this right triangle here. This is 4, this is 5, this is beta right here. And then once I find that hypotenuse, I can then answer the question of what cosine of beta is. Cosine of beta will be the adjacent, which is 4, over the hypotenuse. It will be negative because cosine is the x-coordinate and I'm to the left of the y-axis. So using the Pythagorean theorem, 4 squared plus 5 squared equals c squared. I get 16 plus 25 is 41. So square root of 41 is my hypotenuse. Okay? So now I have all 3 pieces of the right triangle. I could ask you any of the 6 trig functions and you should be able to tell me what the coordinates are or what the ratio is. So in this case, I just want cosine of beta. Cosine of beta is equal to the adjacent over the hypotenuse. It's negative because it's in the second quadrant and cosine corresponds to x. On a multiple choice problem, I would probably simplify it. 50 of them are. -4 root 41, 2 are not.
Oh, that's not bad. Wait, what?
Performance tests are not multiple choice.
52 total questions.
Wait, so how many questions are there in total?
52,
How many multiple choice?
50. Two will be performance tests.
Two,
Which will be
that's the whole 50.
It'll take some time.
It will take the whole. Well, some of you will finish in about an hour and a half, but some of you will need the whole 2 hours 15 minutes.
Oh, yeah.
You won't get any extra time. So if you're ready to start, start. If it's too long, it'll be too long for you and for first period, and we'll adjust accordingly.
Take off full performance test, and about 50, give everyone 100%. And then the final?
That's fine. It's fine unless you have time and a half written into your IP. You're taking the full time. You have 2 hours and 15 minutes. I'd actually use this final when it's been a 2-hour final, so
That still doesn't mean I'm going to get it done in that time.
you'll have to. Make sure you study and know your stuff.
Basically do the performance test first, and then you can guess on the rest of it. If you actually
A lot of students do that, just force test.
Run out of time.
That's a good way to do it. All right, any others on here that you'll see? Yeah. 37, okay. So, we're going to match a cosine function to this graph. So, this is going by ones here. Oh, wait, guys. All right, so I need to kind of look at my graph and see how I've scaled it. Looks like I've scaled it ones here and ones there. So when I mark maybe my high point, so cosine, I'd like to not mess with making it a negative in front. So I'm going to mark maybe here and here as one cycle of my cosine. And so when I do that, and then also look at the high and the low, I think I can find the average in between. That'll be my amplitude. My amplitude will be positive. So I have 1, 2, 5, 6, 7, 8, 9, 10. So 5 down. 1, 2, 3, 4, 5. I think it's -1. So we've got y equals. That means I'm going 5 up, 5 below. So it's 5 cosine of something and then -1 at the end. So I get my vertical shift as well as my amplitude right off the bat. My horizontal shift, I could probably plug that in right away too. It's going to be x -1. I've moved 1 to the right. See where I have this dot here? At least the one I chose. Okay, so I'm 1 to the right. The only other thing I need is my period. The period is measured from 1 all the way over to here. It looks like it's 1, 2, 3, 4, 5, 6 units. So if the period is equal to 6, then b is equal to 2 pi divided by the period, or 2 pi over 6, which reduces to pi over 3. So out front here I have a pi over 3. Now in the multiple choice, this once again, this is not a calculator necessary problem. So y equals 5 cosine, you might see that pi over 3 distributed. Okay, so on a multiple choice you might see that distributed, so look for that. But that's it.